Today in this particular video, we're basically going to cover number system that is present in the world of computers. Starting with the varieties, as you can see from the screen, there are four varieties of number system in the world of computers, computer language I would say. The first is decimal, second is binary, third is octal, and the fourth is hexadecimal. Each number system is found to be different from one another. The difference is the factors by using which you can differentiate each number system would be their number of digits that each particular number system is occupying and the representation of them. So let's start with decimal at first. As I have already highlighted, you can observe here. So here it says that decimal numbers are those type of numbers where we will be having number of digits that is from 0 to 9. What do I mean by digits? That means whenever you will be forming a number, if your combination of digits will be from 0 to 9, which is of course in our numbers world, our digits are from 0 to 9. So with this, we can say that that is the our decimal number. And the base is also very important. This two, number of digits and the base, they both are found to be very much important whenever we are representing any of our number system. So here, as you can see, when the number of digits will be 0 to 9 and when the base will be indicated by 10, I will be considering those type of numbers as my decimal numbers. And here it's already mentioned non-fractional. I have already mentioned an example of non-fractional decimal number, that is 1569. And if I will be considering fractional numbers, then you can see I have taken 1678.988. If you will be observing each digit, that is between 0 to 9. But here I have not mentioned another important thing, that is base. Base needs to be every time mentioned. So if let me write over here, if I have taken 1569, I will be putting a parenthesis and in just base of it I will be numbering it as 10. So now I can say this is completely correct representation of a decimal number. If I will be talking about the fractional number that I have mentioned over here, similarly 1678.988 parenthesis 10 will be said to be as decimal number. Now you must be having a question by writing 10. Why is it necessary to write 10? The answer is that if we will be counting the number of digits that is from 0 to 9, it is 10. So that is what is represented just as the base of the number. Okay, now let's come to decimal number. Okay, you must be aware of the decimal number. This is what our computer understands. So we do also have a rule for it. As we know, every of our binary numbers do only contain 0 and 1. That is what is written over here. So here it says that only 0 and 1 will be the digits that will be forming a binary number, and the base will be 2. Now I have already shown you the reason behind why my base should be 2. That is because it only carries 0 and 1. How many other, if you will be counting 0 and 1 are nothing but 2. So now again my non-fractional number will be 1001100. This is my non-fractional numbers. But if you want to express your binary number to be fractional, then this. But as I have said, the base needs to be declared 1100. Now my base will be 2. Okay, if I will be considering fractional number, it will be 100.101 and my base will be 2. This is how the representation of binary numbers should be. Now talking about octal numbers, as the name itself suggests, oct means 8. So there will be how many? 8 number of digits. But if you will be starting from 0, of course the last digit will be 7. That is what is mentioned over here. It is from 0 to 7. And the base is 0. 0 to 7, if you will be counting it, it will be 8. That is why the base is 8. And again, if you will be observing this this particular number, see 1767. Can you see? 1 is coming under 0 to 7, 7 is coming under the range between 0 to 7, 6 is coming under range between 0 to 7, 7 is also coming under digits 0 to 7. If I will be taking any number 1769, it would be totally incorrect. Why? Because here I have already considered 9, which is not coming under the range that is mentioned. That's why it's completely wrong. Okay. Now if I will be considering fractional numbers, as you can see, every of my digits is coming under ranging between 0 to 9. But if I will be taking if I want to represent it, I will be representing at the base 8, and if I want fractional numbers to represent, it would be this, and my base would be 8. Now we have already understood how to represent our octal number. Now it's time for hexadecimal number. Okay, hexa, most of the time it is also said to be as hexa. Now hexadecimal is actually found to be different from all the number systems that we have just learned over here. Here it says that the digits will be 0 to 1, and that combination of the values that is forming our hexadecimal will also be containing alphabets starting from A to E. Okay, so here 0 to 9 and hexadecimal, and as you can see here the base will be 16. Why the base is said to be 16? If we will be counting 0 to 9, it will be how many? 10 numbers, and A, B, C, D, E. I do 11, this is 12, this is 13, this is 14, this is 15. Acha, see, by this we have got to know one thing, that it's not A to E, but it's A to F. A to F. Let me recorrect this, guys. Acha. Yeah. So can you see, from 0 to 9, if we will be observing, the total number of digits is 10, and other 6 means what? From A to F. So this is my 16th. That is why the base is said to be a 16. And how to represent? Similarly, can you see this particular combination? 1 to A5. A is an alphabet. That is what that can also be contained in our hexadecimal number. That's why I can write this. But representation is not this. I need to put a parenthesis, and in my base 16. Then this one 1, 4, C8, point A1, 2, and base 16. This is how I will be representing my hexadecimal number. You must be understanding how this number systems are, and what all digits are included in our number system. Now another important part needs to be covered about the conversion, because usually you will be getting questions based on this conversion, and actually I have divided the conversion into two types. One is our non-fractional numbers, where I will not be having any decimal number after my decimal places, and I have contained another conversions method that we will be learning, where we will be having numbers after decimal places. So in this particular video I have planned only to cover conversions. Those are non-fractional in nature, and in our later and in our upcoming video I will be teaching you the conversions, how the conversions need to be done if I will be having fractional numbers. Okay, now starting from decimal to binary, listen to me very carefully, then you will be enjoying this. Decimal to binary. So let me take a number, let me take a small number actually, so that things could be properly delivered. Let me take number 13. Okay, this is my decimal number, and what I need to be doing, binary numbers. What's the base of my binary number? It's 2, right? So what will I be doing? I will be dividing 2. Here I will be storing quotient, and here I will be storing remainder. Okay, this is how I need to be doing this. Now let's do. So 2 6 ja 12, base is 1. Now again I will be dividing 6 with 2. 2 3 ja 6, base is 1. Again 2 1 ja 2, base is 1. Okay, and now listen to me carefully. From down to up I will be representing the numbers. So 1 1 1 1. Okay, I have followed from down to up. You need not to be confused about. Okay, this I have written this at first, this second, this third, and this fourth. And now I have already got my binary number, and the base of this binary number will be 2. Okay, I can take another example as well. Let me take 23. Now let me do. I will be following the same thing. Every time you will be dividing it with 2. 2 1 ja 2, 2 2 ja 4. No, this So 22, remainder is 1. 2 5 are 10, remainder is 1. 2 2s are 4, remainder is 1. 2 1s are 2, remainder is 0. Yes, now I will be following the same sequence from up to down. And I will be writing 1 0 1 1 1. And accordingly, I will be writing the base as 2. This is how I will be converting my decimal number to binary number. I hope you must be understanding how these conversions are made. Okay. Now I will be coming to another part where we will be learning how to convert binary to decimal. Okay. Very easy. Just follow all the examples. You will be able to understand. Let me write in a big font size to make you understand. So let me take the example this. Okay. This is my binary number. I want to convert this to decimal. Remember, first step is you need to start numbering from 0, that is from right side. You need to mention here, this is 0, this is 1, this is 2, and this is 3. Okay, this is done. Now, as in the previous case, you have observed we were dividing 2 with every of the quotient of the number. Here we will be raising 2 to the power the base that the number that I have right now mentioned. So it will be 2 to the power 0 into whatever I am having. What I am having here? I am having 1 over here. So 1. Then I will be adding. Then again 2 to the power, what I am having? 1 into the number. Then again 2 to the power, what I am having? 2 into the number, that is 1. Then 2 to the power 3, then into the number that I am having. Okay. Now you must be observing. Have you observed this very carefully? These are nothing but my 2 to the power. Everywhere I need to number it as provided over here. And I need to multiply with the number that is present over here. Follow this. I have multiplied everywhere. Everywhere my 1, wherever is present, I have multiplied with that particular binary number. And at last I will be adding them up. And let's see what result I am getting. So anything to the power 0 is 1. Then 2 to the power 1 into 1, it's 2. 2 to the power 2 into 1, it's 4. 2 to the power 3 into 1, it's 8. So at last I will be adding them up. And it's 13. Can you see? The answer is 13 over here. If I will be observing this particular thing very carefully, I have taken the same binary number that we have got in the previous example. In our previous example, our decimal number was 13, and when we had converted that to our binary, what result did we got over there? The result that we have got over there is 1111. I have taken the same thing and now I have converted into decimal. Can you see? In both the both this particular example, we have got this same answer. Now representation is very much required. I will be representing it with 10 because this is decimal, and as you can see I have represented with base 2. Now I am confirmed that you must be understanding what I am doing actually, right? Okay. Now let's learn how to convert my octal to binary. Octal means what? I need to take a number that needs to be ranging between 0 to 7 digits. Digit of the number should be ranging between 0 to 7. So let me take 1 3 5. This is my octal number. Okay, every time in the question itself you need not to be confused about. Here I have written in the heading, that's why I'm considering this to be as octal number. But if you will be getting anywhere 135, you must be confused enough that is this a decimal number, or this is an octal number, or this is a hexadecimal number. You need not to be confused about. There you need to observe the base. If the question is given directly, where in the heading it's not mentioned it's an octal number, then you will be observing, you need to observe the base, and here the base is 8. Okay, now what I need to do, just see how I will be converting this particular number to binary. Remember, in our octal number, the steps are: take each digit, convert it into binary, and represent it with 3 digits. Okay, what do I mean by this? See, here I am having from right to left, and that's from right to left. From anywhere you can do, from left to right also it's okay, but I always suggest my students to do from right to left. So now I have already taken 5. If you will be converting this particular 5 to binary number, I am directly writing the result. If you want to calculate, you can calculate it. You will be getting result 101. Okay, it's done. Now can you see, is this represented in 3 digits? Yes. See, am I following the theoretical part that is written over here? Take each digit. I have taken 5, I have converted into binary, and I have represented it in 3 digits. Okay, I have represented it in 3 digits. Now let me take another number, that is 3. Now let me convert it. If you will be converting 3 to binary number, then you will be getting answer as 1 1. Okay, but here as per our theory, I need to represent it with 3 digits. How to represent a number with 3 digits? That just add a 0 left side of it. If you will be adding a 0, then it's no value, right? That's why I have added 0 to my left hand side part. Now it's my 1. So if I will be converting 1 to my binary, so it will be 1. Now what I need to do? I need to represent it in 3 digits. So another 2 zeros just left to it. Okay, now my task is done. Now I need to write them out combinedly, 0 1 1 1 0 1, and I will be putting a base as 2. This is how my octal number will be converted to my binary. Understood? I hope you must be noting it down, whatever I am explaining over here. Now binary to octal. What if a particular number will be given binary to octal? Now let's learn. So what I need to do? See, underline pattern or sequence, pattern of 3 digits that is mentioned, and convert each binary 3 digits pattern that you have extracted out, pattern, to decimal, and then you are done. See, let me take a binary number. Suppose I have taken 1011101. So what does it say? I need to underline 3 digits, and again this is from right to left. So what will I be doing? I will be underlining. I need to make a pattern. This is my 3, and this is my 3, and here I could only find 1. So what I need to do? Add 2 zeros and make it as a pattern of 3. Now can you see, every of my part or every of my combination is of 3 digits. Now let me convert it to what? Decimal. So if I will be converting 101, if you will be, as I have already said you how to convert binary to decimal, if you will be following the same sequence, you will be getting 101 is nothing but 5. And if I will be taking 011, the answer is 3. If I will be taking 001, the answer is 1. See, it's done. Now I will be putting parenthesis, and I will be writing 8 at the base. See, if you will be observing, I have taken the same combination that we had extracted out. See, previously our decimal was this. When I had converted my octal to binary, previously my combination of binary digits were this. Now when I have taken the same thing to convert into octal, you must be observing. Now I have already got how to and I have got the same answer. See, 135 at the base 8. I hope you must be following what I am saying right now. Just follow whatever description I am writing over here. Just follow and try to use it with other combination numbers. You will be getting how the things will be done. Now it's time to learn about how to convert hexa decimal to binary. So similarly, let me take hexa. So A5. Okay, if this is my hexadecimal, base 18. As I've said, hexadecimal do contain alphabets. Okay. So before this, do remember students, 0 to 9, and if I will be breaking A to F, do remember my A is nothing but 10. B means if you will be getting such particular thing in our expression, you will be considering A to B as 10, B as 11, C as 12, D as 13, E as A, B, C, D, A, B, C, D, E, F. Am I going wrong somewhere? So 0 to 9. This is 15. Yes, correct. So what happened? Here I need to follow this similar process. Let me write down what process need to be used. So here you need to take each digit. Okay, step number 1, convert it to binary and make it to 4 digits. That's all. Previously you must have observed in our octal I had converted it to 3 digits. I had manually made 3 digits. If at any place I have not got, here what I need to do, I need to consider each digit and I need to convert it into binary and I need to represent it in 4 digits form. Okay, that's all. Now already I'm having 5. What's the binary form of 5? 101, right? So 101 I will be writing. But only writing 101 is not self-sufficient. I need to change it to combination of 4 digits. So let me add a 0 just back of it. Okay. Now I'm talking about A. A, as I've said, you cannot convert A directly to the binary digits. That is why I have written A is nothing but 10. So what's the binary digit for 10? I think it is 1010. Yes, it's 1010. If we will be converting 10 to binary digits, it will be 1010. 0, 1, 2, 3. Yes. Now it's time for 1. What's my binary digit for 1? It's 1. It's 1 and I need to make a combination of 4. That's why I have added 3 zeros. Now my task is done. See, my hexadecimal is successfully converted to binary. Okay, see, it seems to be very easy, right? Now I will be following. See, if you will be finding octal and hexadecimal, most of the concepts are relatively same. Only the one thing that you need to consider is there you are making combination of 3 everywhere. Here you will be making combination of 4 everywhere. Now let me write binary. Okay, let me take 110100101. This is my binary. Now I will be converting this to hexadecimal. Okay, so let me write what steps need to be followed. Make 4 combination. Make 4. I could say that make 4 digits combinations. Convert it to binary. That's it. Convert it to decimal. Finish. See, from right to left, everywhere, dear. Right to left is the one that you need to follow every time. So here as well I will be following. See, this is my 4, this is my 4, and wherever I will not be finding that it's not my combination of 4 digits, as 0, 3, 0. Now it has become my 4 digits. Okay, now what will I be doing? I will be converting it to decimal. 0101, it's 5. 1010, it's 10, but I cannot write 10. I cannot write 10. In place of 10 I will be writing A. Now 0001, if I will be converting it to decimal, it will be 1. See, 145. successfully got converted to hexadecimal. If you will be observing very carefully, I have taken the same thing. Previously I had taken 145 and I had converted to binary. Now as I have taken the same binary digits number, and now I got to convert it to hexadecimal. That's it. Okay, now we are going to learn another interesting part where I will be converting from octal to decimal, decimal to octal, hexadecimal to decimal, and from decimal to hexadecimal. Okay, this particular video is the part 1 video. In my part 2 of the video, I will be converting these all combinations. Okay, if you have learned something valuable, make sure that you will be liking to this particular video, share with your friends, and comments your feedback after you have watched this video till end. Okay, and keep practicing taking different combination of numbers and the conversions. So there will be actually, I think, 4 parts of this particular chapter where all the conversions will be made. This is the part 1, and part 2 I will be converting only octal to decimal. This particular part of non-fractional numbers will be done, and in our coming class I will be focusing on the fractional numbers, and accordingly the whole particular conversions of this particular chapter will be completed. Okay, so stay tuned, subscribe to this particular channel, and press the bell icon for getting updates. Thank you for watching, guys. Bye bye.